Hi, welcome to Moose and Chemistry, Reaction Stoichiometry, Limit Excess Reactions, Lesson 1. In today's lesson, we're going to learn how to find the limited excessive reactant of a particular equation. The black oxide of iron, FeO3O4, occurs in nature as the mineral magnetite. This substance can also be made in the laboratory by the reaction between red-hot iron and steam according to the equation Fe plus H2O yields Fe3O4 plus H2. So when we have 36 grams of H2O is mixed with 167 grams of iron, which is the limiting reactant? Well, first of all, let's identify who the reactants are. This is a reactant and this is a reactant. So one of these guys is the limiting reactant and the other one would be the excessive reactant, which means we have more than we need. The limiting reactant, whichever one it is, determines exactly how much of the product that we can make. Okay, now we have, in this case, we have these in grams. So we know we have 36 grams of water, right? So we go 36 grams of H2O times 1 mole of H2O, because we want to turn those grams into moles. And we'll divide that by 18.02 grams. Where that 18.02 grams come from? That's the molar mass of hydrogen. Remember, hydrogen is 2 times 1.01. O is 1 times 16.0. This would give me 18.02 grams. So go ahead and look at that. And that's where this number comes from. So just kind of look at that because I'm getting ready to make it disappear. Okay, there we go. And we're going to erase the rest of it, of course. So now you know where that number came from. Let's get back to the lesson. So we cancel out our grams, and this makes exactly 2.0 moles of H2O. Well, you can already tell that if we did this reaction, you see there's a 4 here. So we need probably 4 moles of water to make this work, but let's just make sure. Okay, so we'll take the 167 grams of the iron, right? And we're going to find out how many moles of iron that makes. So it's 1 mole over Fe over the molar mass of iron, which is 55.85 grams of iron. So where did you get that number from? From the periodic table, of course. So that cancels out. And this makes exactly 2.99 moles of iron, which is the same thing as 3 moles of iron. So that makes enough to satisfy this part of the equation. But let's just double check to make sure we're all good. So what we're going to do is we're going to find out from the equation how many moles of water is required, right? So we're going to test out the water to see if it's the limiting reactant. So I've got a feeling that it is, but let's go ahead and just do the math just to make sure. So, okay, we're going to take 2.99 moles of iron. That's what we found. And we're doing the mole ratio. So we got 3 moles on the bottom of iron. And Fe, and we're getting 4 moles of H2O. Where'd the 4 moles come from? Right here. Where'd the 3 moles come from for the iron? Right here. So take a look at that for a moment. And we're going to get rid of that. Okay, so now we're going to cancel out our moles. And this is going to tell me that I need 4 moles of H2O. This is what I need. And this is what I have. Do I have enough to make my needs? And the answer is no. I only have half of it. So since that is true, that means that the H2O is the limited reactant. And by default, that makes iron the excessive reactant. Okay, well, it's been great having you here, guys. This is just a quick introduction to this, and we hope to see you again on Moose and Chemistry. You guys have an awesome day.